Here are more examples related to taking derivatives of functions. In this example, let's find the equation of the line tangent to y equals x to the third minus x at x equals 2. Okay. Well, first of all, we need to know the derivative. Remember, the derivative tells us the slope of the tangent, so the derivative of y with respect to x is going to be the derivative with respect to x of x to the third minus the derivative with respect to x of x. And of course this would be, using the power rule, 3x squared. And of course x is just x to the first, so this would be minus 1 times x to the 0. All right, and that will simply be 3x squared minus 1. We've seen that already. Okay. All right, now we're finding the equation of the line tangent to the curve at x is equal to 2. At x is equal to 2, all right, notice the x value will just be 2. The y value will be given by this formula, 2 to the third minus 2, which would be 8 minus 2, or 6. Okay, and the derivative gives us the slope of the line. So if I take the derivative and using the Leibniz notation to evaluate it at 2, I would write that like this. This notation, this bar with the x equals 2 at the bottom, just says look at this derivative, which is 3x minus 1, and evaluate it at 2. And if we do that, that would be 3 times 2 squared. X gets replaced by 2 minus 1, or 12. All right, 12 minus 1 is 11. So, all right, now we're ready to write the equation for the line. If we look at the point slope form of a line, the point slope form is y minus y1 is equal to m times the quantity x minus x1, where m is the slope of the line. In this case, the slope is 11. And the point on the line is x1, y1. Well, on this line, we have the point 2, 6. So the equation for this line, is going to be y minus y1, which is 6, is equal to m, the slope, 11, times the quantity x minus x1, which is equal to 2. The only thing we might do is put this in slope-intercept form, solve it for y, and we could rewrite this as y is equal to, multiplying through by the 11x minus 22 plus 6, and that would be y is equal to 11x minus 16. Okay, all right, let's go on to another example, and the other example says this. Let's for this function y is equal to x squared plus 3x minus 4. Let's find dy dx, and this notation again, what does that mean? Dy dx evaluated at x is equal to 1. So the first thing we'd have to do is find dy dx. Dy dx is equal to the derivative of y, which is the derivative of x squared plus 3x minus 4, and that's going to be going term by term, the derivative of x squared plus 3 times the derivative, taking out the constant factor, of x to the first, minus 4 times the derivative with respect to x of x to the 0. This would be 2x to the first, using the power rule. The old exponent comes out in front, the new exponent is 1 smaller, so it's 1, plus 3 times, well, this is x to the first, so it would be times 1 times x to the 0. X to the 0 is, of course, 1, minus 4 times, all right, using the power rules, 0, x to the 0 minus 1, or negative 1. So notice that this would be 2x plus 3 times 1 minus 0. Okay, so dy dx is 2x plus 3. Then dy dx evaluated at x equals 1 is just this expression where each instance of x is replaced by 1. So dy dx with x replaced by x equals 1 is 2 times 1 plus 3. That would be 5.